I hope you are fine. Today I'm going to present another app. And the idea behind the app is that you have seen the linear programming app function within Excel where you give a constraint optimization question and details and then you minimize and maximize. This app is inspired from that, but the difference is that here the objective function will come from the regression and then it will ask you the boundary conditions for the independent variables and also the dependent variables so that it can optimize you the solution. And if you give the cost details, it will also tell you what will be the cost. So I will give you details. So the derivations are shown here, all which are being used in the function. I will load a certain data file. You can manually insert the values also, but what I will do, I will load a data file and you can upload CSV, XLS files. You can, if you click here manual, it will give you a matrix. Matrix will be like when you come here, you select the dependent variable. I select this variable and this and this variable. So I selected 3 independent variables. When you select this, it will start estimating the regression model, simple regression model. But if you wanted to use a complicated regression model for your objective function by estimating panel data or any advanced model, you can click manual and then it will give you this matrix. You write the variable names and add more rows if you need, write the slopes. And then, so I know the min and max of this variable. This is from 0 to 10. This is also from 0 to 10. And this is also from 0 to 100. I have another variable. I will add it so that because it can also be negative. So I will just add it. So it will update the descriptives. From the descriptives, you can, so this is the regression results and the detailed results are here. If you want to see, it will give you all the other details that panel data, simple regression in Python that can give. So if stat is significant, you can see all of the variables are significant, means they can be used as constraints in the model. So we have this. So I will start with 0 to 10, 0 to 10, and 0 to 100, and minus 2.5 to 2.5. So I have given this range. I also know my dependent variable is from 0 to 1, and I want to make sure I need to achieve 0.95 target. So I will say 0.95. Okay. And then I will talk about this. So target based. Okay. And then when you see intercept is given, it picks from the intercept of the model. It will say that the model feasibility is this. The model is from 0 to 1, but you can only achieve 0.87725. So maximum you can go up till here. It means the maximum value from these independent variables can be achieved till here. So what you can do is now you start with this. So 0.8, I will start with 0.877275, or maybe just round it off 0.877. I want to achieve this. So it will tell that you will be able to achieve this in this. Only HC is non-binding, others are binding. So it means there is constraint that you need to increase so you need to decrease CHR because it has a negative effect, but you cannot go less than 0. So it has used 0, but you cannot go less. That's why it is binding. Q of GI is negative. You had to. It's already 0. Cannot go less. It is positive, so it should go higher. So it's bounded by upper limit. But this variable, you can stop here because beyond that, it is not increasing that outcome. Okay, so this is outcome, and then you can see the contribution of each variable. So RQ has most role in achieving the target, then HC, then these two variables which has very low value. And then you can see the range of the variables. So RQ achieved the highest, and then QFGI is the minimum, CHL minimum, HC almost maximum. You can download this solution also. And then other things you can see is that in the sensitivity analysis, you can see the level values are used. We can add the cost values also. Okay, so it is saying, see, uh, it is giving you the shadow price, that how much cost we are going to pay if we are not able to achieve the highest point, and then here how much cost we are going to pay if we are not able to reduce further. Okay, so now what I can do, just let's add some cost. Let's say I say the 1 unit increase in human capital at C, I need 5 million per 1 unit. I need for CHL maybe 2 million, for QF maybe 3 million, and for RQ maybe 7 million. Okay, so I added the values. So what it will do, it will also start calculating the cost. So it will tell me that the cost that achieve is 67.12 million. Okay, and then it has given me the details. Now you can do further things like, uh, I will show you more features in this app. Further you can do is you can optimize, minimize, or maximize within bounds. So I wanted to maximize y, and then out of all optimize y, I needed to minimize the cost. So what that will do, it will come here, it will use the same table, and then it will check that this is my y optimum, and it will give me the cost. Okay, so technically it will be the same answer because we are maximizing, but if I say y minimize, it will update. So it can say that it can minimize to minus 2.4, but you cannot do so. So it will stop at, it will not go till that point. Okay, so it's still abounding, so it will go till 0. Okay, so another thing you can add is this you can see allowing the error lexicographic tolerance, and if you can add more constraints for your independent variable, like you can say that a particular independent variable should not be. So let's say we come back to our target based, and then we have the objective function 0.877. Okay, so this is maximization question. If you convert it into minimize minimum deviation, yeah, so this part is under development. Okay, and then it's also under development. So that part connects with other parts of the question. So we have this target objective. So this is achieved here. So this is simple constant optimization. Now I wanted to say, so in this video, I was talking about these features. So here you can enforce the budget also, because when we reduce this budget, it's so that it will cost us this amount. So if we can add a limit that we no need to go beyond that, so it will find a solution within that cost. So if it's not able to find, it will tell that there's no feasible solution. Other extra constraint features are there, and they are under development. So I will share them when they are developed, and then the tutorial will be available there for complex decision making. Okay, the link for this app will be shared in the comments. Thank you.